Alright, this is a 1977 Otis Baker forklift, and probably if you have an older American forklift, it'll use the same threads as what this forklift uses. I had a tilt hose that I needed to replace, so this center lever here operates the tilt, so you can... So this one, when you pulled it back to try to tilt, it just sprayed fluid on the ground. So I think probably only one of the hoses was busted and leaking, and I think it actually came in half. But of course, these rubber hoses are from the 70s, so they're old and dry. And because this holds so much pressure, so you imagine if you take this tilt back and you have something heavy like an engine, which I've moved a 7.3 IDI diesel engine with this forklift. That's a lot of pressure. That's a heavy engine, and it wants to tilt forward, and the only thing stopping it from tilting forward is these tilt cylinders holding pressure, and those lines holding pressure all the way back to this valve. So if I just replace the one hose that's leaking, the other hose, even though it wasn't leaking, it's old and dry, it could conceivably pop, and the whole load could and kind of fall forward. Now, it doesn't fall very far. You see, this has no tilt on it, and it's just a very slight forward angle. But the same thing would apply to a lift cylinder. If you break a hose, I've been told it sounds like a gunshot, and of course your load will drop, assuming you have sudden failure, which with the crispiness of some of the hoses on this, I find to be very plausible. So what's really neat is you can go online and you can find charts for ORB and JIC. Now, probably, if you have an old American forklift, probably it's a JIC thread. Now, AN, I believe, uses the same or very close to the same thread as JIC. However, generally, AN is aluminum, it's automotive, and it's rated for lower pressure. And I think some people had said maybe that it was a slightly different thread pitch, even though it has a 37-degree flare angle. And so let me show you here. That's a 37-degree flare right there. Now, if you go to the hardware store and you get plumbing, it's going to be a 45-degree flare. So AN and JIC are 37-degree. I may have been told at one point that you could jam a 45 and 37-degree flare together and get it to seal. Obviously, I will not be doing that. I do not recommend that. Furthermore, the plumbing flare, generally the fittings are brass, so it's kind of soft. So, I wouldn't want to trust brass to the, 3,000, 4,000 pound hydraulic pressure that this can produce. So same thing with AN, they tend to not be rated for the pressure, and the fact that it's possible the thread pitch is slightly different. You don't want the threads to get tight before it has a chance to seat the flare. So obviously you're going to want to stick with JIC. So now this here is your must-have tool. You use this all the time. When you're working on stuff, it comes in way more handy than you might expect. But when you look up the neat charts for JIC, for example, it'll actually tell you the ID and the OD of the thread. So you can actually, with two hands, correctly measure this, not like I'm doing now, just like that. And you can measure, maybe I should zoom. Yeah, no. Yeah, just measure the outside of those threads, and it actually gives you that measurement, and you can come up with a few thousandths, within a few thousandths of what the chart says. And it also gives you, ID. So you could, for example, measure inside whatever you have easily available to you. So both of these, I believe, no, these are different. I'm getting confused. Anyway, this is 3/8 JIC. So the hose is generally a 3/8, and this is a 9/16 by whatever thread pitch. Same thing here. But yeah, so if you only have, for example, the female, available to you, you can measure that, and it'll tell you exactly what it is. So this is a -6 JIC, and I usually look it up as 3/8. Stuff on the internet, when you buy it, it doesn't tend to have the -6 as often, and that's the other thing too, is you can have different ends on a 3/8 JIC hose. So, it's really confusing, but you want to pay attention. 3/8 JIC hose, and, if it says a thread, you know, it's going to say 9/16 by 18 or 16 or whatever it is. So yeah, if it says 9/16 thread, that's correct, because obviously the thread is much bigger than that 3/8 inner diameter inside the hose, right? You know. And so part of what you want to pay attention to is my hoses were probably custom made for this, and you can get hoses custom made, but in my case it's going to be cheaper to just get a hose pre-made online, right? So it was 3/8 JIC up here at the valve, but then it was 5/16 JIC over at the hydraulic cylinder. So in my case, it's easier to get a JIC female in, you know, 3/8 anyway, you know, the same end on both ends, right? And then I would have to adapt, because now the 3/8 is too big. As you can see here, that's what this is. The 3/8 is too big to fit on. So at first I had thought perhaps I would get a you know, 5/16 female JIC to 3/8 male JIC, but I had also considered that this fitting would unscrew from the cylinder, and you know, a friend of mine mentioned that this is a ORB, O-ring Boss, and so here I ordered, I think, 5 or 6 of these. I only needed 4 so this will have the 5/16 O-ring Boss, and we know it's 5/16 not because it has a 5/16 JIC on the other end, but because we measured it. So we measured this JIC fitting, we measured this O-ring Boss fitting, we measured the JIC fitting on the other end of the hose. So you got to be very precise, or else you'll end up with something that doesn't fit, right? So now I ordered these adapters, and so I can unscrew the original adapter that went into there, and I can screw in my new one, and now I can fit a standard, you know, 3/8 to 3/8 JIC hose, instead of having a different end on both ends of the hose, which kind of requires me to have a custom one, which you can get. I don't think if you get a custom one on the internet, it's not terribly expensive. I called Napa. Their custom hoses are pretty pricey, so for about half the price I could get a hose online as opposed to going to Napa. Now, of course, I did make a mistake. It's a little dark in here, but perhaps that helps a little bit. So I was so focused on this having the correct thread, and also I figured, well, this is an elbow, so it doesn't matter which direction this elbow points, right? You know, obviously you don't want it to hit the brake pedal here, but if we just point it down, as long as I have some extra hose length, I can just point it down somewhere where it's safe to run the hose, where it won't get entangled in anything that moves. And, you know, I can have this in whatever orientation. But of course, what I missed, I was so focused on the thread, this won't screw in. You see that? It hits the cylinder. So, oops. So I had to order a couple more of these adapters that are straight. What came out of here was straight, and I just, you know, goofy mistake. I thought maybe I could replace it with an elbow, and I cannot. So, you know, all of these variables, and I'm trying to pay so much attention to all of these different threads and different fittings that I need to put this together to make it work. And, you know, sometimes things slip through the cracks and you miss a little bit. And so as far as replacing hoses, that's probably all you need to know. Have a caliper. The digital ones are really cool, and the stuff they make nowadays is pretty accurate. So you don't have to worry about, oh no, it's like a, you know, computer mouse with a laser on a trackpad, it's going to be inaccurate. No, this works, you know, awesome. And they're not very expensive. So it'd be nice to have a caliper, and then just, you know, JIC O-ring Boss. And you can actually see here, excuse me, there's your O-ring, and I assume the other end is the Boss. So this must be the worker. Anywho, now I had to replace a bearing on this mast, and this has been kind of a disaster. And so that right there is what a quote-unquote good bearing looks like. There is a snap ring retaining it. It is technically on camera. I don't know if you can identify it. I can actually see it. Snap ring, bearing, pulley, and the chain. See the chain there goes over that pulley. And over here is my bad bearing. And you can perhaps see the difference. The snap ring is gone. The bearing is gone. The outer race remains. The inner race appears to be gone, as far as I can tell. And so, how do I get that friggin' thing out of there? Well, first I figured this mechanism, you see that pulley is behind this whole assembly here, so that assembly is what the hydraulic cylinder mounts to, and it adapts and it allows the hydraulic cylinder to mount to that portion of the mast. And it also, of course, contains these rollers for this hydraulic hose. So what I ended up doing is I took out, these are fine thread bolts, 4 of them. And so now you can kind of see this is a lip. Then that's kind of what I think the weight goes on. Anywho, I took out those bolts and I lowered this whole bracket assembly down. I figured that would allow me to move that pulley forward. Sadly, there is room in there, but over here on this side there is not quite enough room, and this pulley hits the mast. And so here I've actually taken, you see those chains are off. Obviously the chains have to be unloaded before you unbolt them, or else they'll kind of explode in your face and heavy iron stuff will start falling, and that's dangerous. And I also took off these hydraulic hoses for the side-to-side mechanism. That's what that third lever is for, is it actually moves the forks, left and right. You got to take those off, or else you'll lift up the mast just by the hydraulic hoses. Oopsie daisies. You also have to have the block. So this block, this wood block here, don't be confused by the jack. The jack is holding up the fork assembly, but this block here, and you notice I have a two-stage mast, right? So I have 2 hydraulic cylinders. So you notice the block of wood is on that inner piece, that inner race, and then this outer one is left free. So that outer one is the chains. In other words, if that outer one hit the wood block, these chains would not go low enough, and you would therefore not be able to put the chain back into that hole, right? So you have to have that intermediate one be able to move freely so that you can actually lower the chains back down and put the nut back on. And I found that out the hard way. So I did actually lift up the mast by the hydraulic cylinders, which I had done once by mistake. So if I broke those lines, if they leak now, they were probably already broken just because I forgot to disconnect them. And so yeah, now when I go to reassemble, yeah, that one piece will move down, and that will be the chain. The chain will move down. The wood block is effectively on the chain mount, so that's up. It is in some position other than the minimum position, because without that wood block, this would probably go basically to its mechanical limit, and I suspect the chain wouldn't be long enough to reach, and that would be kind of annoying. And so this allows it, that wood block holds it up enough that when you put the chain to the chain's lowest minimum position with the hydraulic cylinder and with the engine running, that gives you enough chain that it'll actually go through that hole, and you can tighten the bolts before there's ever weight on that. Now, the whole purpose of that is, now that the chains are disconnected, I ought to be able to, and I haven't proven this yet, I ought to be able to lift up that hydraulic cylinder and lift up this rear mast, and thus leave the front mast stationary, and I can go past it. And when I go past it, that'll allow that pulley to go forward, and it won't hit that front mast. It'll have nothing in front of it blocking it from coming off. Now, there is one more problem. Of course, the bracket on this hydraulic cylinder appears to want to block that pulley from coming off. And yeah, the pulley might come off now because it has no bearing, but when you try to install it with a new bearing and it's a tight fit, it has to go on straight, that bracket will get in the way. So probably what's going to happen is I will use the engine and the hydraulic cylinder to lift that. I'll then put a big wood block in there, and then I will lower that hydraulic cylinder. Thus, that'll be up in the air, supported on a wood block. It won't have that front piece in front of it, and it won't have the hydraulic bracket in front of it. And so I'll probably replace both bearings once I get it off and once I get it measured. That way I can, I don't have to do this job again because it's so complicated and miserable. And of course, once I finally got this all unbolted and I thought I was ready to actually lift, the forklift failed to start, and the starter solenoid is now open circuit. I don't know. I'm going to test and see. It's possible it's not getting power, or it's possible the coil itself is somehow broken or damaged. So either way, I got to figure out why it no longer starts. But that is basically what we are doing with the forklift. Yeah, it is propane, and the mixture is a little bit weird. Not enough propane, and it like runs hot, and too much propane, and it'll actually, melt exhaust valves because then it's too hot also. So it's kind of weird. You got to get the propane mixture just right, or you'll kind of damage the engine in either direction. Normally with a gas engine, it too rich or too lean, and it won't want to run. Too rich on a gas engine, and it tends to run cooler, and you get black smoke, but it won't actually melt an exhaust valve. And in the case of propane, too rich, and the combustion mixture gets too hot. It's a whole thing. So I got this, I had it down one rotation on the mixture. It was too lean and it was kind of weak and it didn't make power. I cranked it up one turn and it made good power, and I left it there. So it should be on the leaner side. That's with this mechanism here. It's a little tricky to see. I can only do one rotation on this because one of these nuts is completely rusted. And I learned the hard way. This is a ball and socket, and the ball appears to be made of lead or zinc, some very soft metal. So if I apply any rotation to this here, you see that's a knurled. It's meant to be a thumb wheel that you operate with your fingers. So you loosen the jam nut and you twist that thing, and you can get a very fine, minute adjustment. Well, if you apply any force at all to this to try and break that nut loose, because the nut is rusted and stuck on there, you'll twist that ball right off because it's lead or zinc, something very soft, has no strength to it whatsoever. So up here, I just I unbolted, the ball mount that whatever remained. It has a thread on it and everything. You unscrew that. I just drilled a hole straight through here, and I put a bolt straight through and a nut. It's a Mickey Mouse fix because this is kind of thin aluminum, and that's basically now my bearing is just that thin aluminum tube. It's just hole drilled perpendicular to that tube, and it's rubbing against the bolt. So this won't last terribly long, and it'll start to wear, and this circular hole will gradually become oval shaped. But every temporary fix is a permanent fix as long as it doesn't break. So basically, forklift works now, and I'm not going to touch it as long as it works. So given how often I operate this forklift, this will probably last me a very long time. It's not like it's in a warehouse setting where it's being driven, 8-10 hours a day. The old brake master cylinder was completely locked up. The pedals wouldn't even, you'd step on them and they would move a little bit for the slack, but the cylinder didn't move at all. It was completely rusted. So I bought a brake master cylinder. Some of the early, I want to say like 50s Chevys or something used a master cylinder like this, but it's more expensive. So the cheapest master cylinder I could find was about $20 or $30, I want to say, with free shipping. I don't remember exactly, but that was the cheapest I could find. And it fit a Jeep, I want to say CJ4, in the late 50s up until 67 or something like that, 1967 and earlier, CJ3 maybe, brake master cylinders. And when it showed up, this adapter and everything was part of the forklift, and I unscrewed it from the old master cylinder, and the threads on the new master cylinder exactly matched, and it all screwed together, so that was awesome. And those two bolt holes were in exactly the same location, and they were exactly the same diameter. And so I smacked a new brake master cylinder on there and bled it, and now I have brakes, so that's excellent. I also I had adjusted the advance on this. I tried to give it a sniff more advance, and this thing would not start. So I ended up pulling the plugs, and they had, I want to say, 35 or 37 thousandths gap on them, and propane is hard to ignite. So I brought that gap down to about 20 thousandths and put the plugs back in, and then it started, and it's started ever since. So it was just, with whatever amount of advance it had, it was just borderline, would just barely start, and I just tweaked the advance a couple of degrees, and it never started again. So 20 thousandths on the plugs, and I think the advance is a bit sensitive to mixture, which is similar to a gas motor, but yeah, if you have a leaner mixture, I forget, you have to give it more advance or something. I don't know. I just kind of tune it to taste. You bump up the advance until sometimes when it's cranking, you'll tell it wants to fight, where it fires, and instead of taking off, it kind of, and it almost wants to fight it and go backwards. And there's a spectrum of that. So once you get that sort of struggle on cranking, you just back it up until it no longer does that. And you have enough margin that even when hot, you know, it never wants to backfire when cranking, and that gives you a fair amount of advance. It gives you a fair amount of power. Although I think on this one, I might have even retarded it a little bit farther. And it seemed like it liked that. Just a little bit of... I think on probably a gas motor, I would have left it closer to the, you know, maximum of advance without fighting. But I think on this, I ended up retarding it a little bit more, and it seems like it likes that. And this is a new hydraulic filter, 51551. Apparently that's a very common, you know, quote-unquote universal old hydraulic filter. So probably if you have an older forklift and it has a hydraulic filter, that's a likely number to fit. The oil filter on this was interesting. Had a very, very, very small thread, much smaller than most cars. You think of the smallest thread you've seen on a car filter, and it's smaller than that still. I have one here I can show you in a second. And I happen to have a couple of filters laying around that fit, so I haven't figured out a part number for that yet. I just put one of my off-the-shelf filters on it. And this here is the filter I put on it that fit. And you notice cars, small trucks, etc. I suspect this is a bypass filter or like an aftermarket filter or something to that effect. This filter on the forklift screws onto a little bracket assembly, and there are oil lines that go to it. So this filter doesn't screw onto the engine or onto an adapter bolted to the engine like you would expect. It's just a kind of, it almost looks like a universal aftermarket adapter bolted to a chunk of the forklift with a couple of lines running to it. And so you can kind of see here, yeah, you see how small, you know, I have kind of skinny fingers, but yeah, you see how small that hole is. And so I figured I had a filter on the shelf that had a small hole like that, and it was an old filter, so I figured it was probably a, you know, SAE thread, and sure enough, it screwed right on. That filter was a little bit taller than the forklift filter, so it sticks down a little bit farther. It does stick down under part of the body of the forklift, but there's still a cross member that sticks down even farther. So it's within the realm of possibility. You could hit that filter on a rock, but it wouldn't high center on the filter. It would high center on the cross member before it high centered on the filter. So anyway, you know, probably not the safest, but yeah, I don't imagine I'm going to hit it. And if I do, I'll see oil on the ground. So. And so the only other thing that I would probably add is that this is an F-168 Continental engine, not an F-167. The 167 was older and had the starter in a different location. So there's the starter right there. I know it's a mess. It's hard to see, okay? But it's kind of located near the top of this bell housing. Like, you know, not exactly at the top, but near it. And you can kind of see, hopefully, that bell housing there. I'm moving this around to give you a little bit of a 3D effect. So it could conceivably go down lower, but it's up pretty high. That's the F-168, newer engine. The F-167, as I recall, the starter's mounted in the lower position. And I believe I have those numbers right. If I've made a mistake on the exact displacement I'm citing, forgive me. But anyway, so you can look up, for example, the dwell angle on this, and you can get a dwell meter. I don't have mine on me, but it's super handy. That basically the dwell meter sets your points gap very precisely. It's literally the dwell angle is how many degrees the points are open versus closed. And especially if this is propane and it's hard to ignite and it's sensitive, you know, it's useful to have that dwell, you know, set closer rather than not. There may be a slightly different dwell for propane, I have no idea, but you can look it up for the F-168, the exact dwell angle, and it'll tell you online. You can look up all sorts of stuff. So if you have an engine like this, some flavor of Continental, that might help you too. There's a manual online you can download specifically just for the engine, and these are put in all sorts of things. The F-168 specifically was put in some Lincoln welders. So a lot of the information online is for the SA200, I believe. I believe that was it, and it was a Lincoln welder. So a lot of guys that have information on this engine, it's in relation to that welder specifically. So I think that's just about everything that I've learned about this forklift along the way. So hopefully some of that information is useful to you, and perhaps if I learn anything else earth-shattering, I might share it along the way. Hopefully that makes it a little bit easier for you to fix whatever you're working on.
Yeah, man. There it is. So this is super crazy dangerous. That right there is Balin Mania, and we are gonna do something really stupid today. This is a terrible idea. Balin might die. It's making me uncomfortable. Go, Balin!
You riding this?
What the fuck is happening?
Balin said not to talk crap about this camera. It's a piece of shit.
This is so unbelievably sketchy. Why would you put me through this, you jerk?
That's the power of really old engineering.
It'd be nice if it didn't kill me. It's not required.
I felt it fucking pop.
Make a wish, everyone. Make a wish.
Not okay. You went too far. This guy, man. This guy.